All right, welcome to the Explainer. Today, we're going to pull back the curtain on the complex world of modern software development. We're breaking down how the digital tools we rely on every day get built, from that first spark of an idea all the way to the cloud.
So, have you ever really stopped to think about how the apps you use every single day are actually built? The whole process can seem ridiculously complex, right? It's just a sea of buzzwords, containers, microservices, pipelines, and it can feel pretty overwhelming. But what if we could simplify it?
Let's try. Think of it like we're building a digital city from scratch. To do that, you're going to need a blueprint, some building materials, a factory, and of course, a killer assembly line. This metaphor is going to be our guide for this entire explainer, so let's jump right in. Okay, so every great project starts with a blueprint. In the software world, that means choosing an architecture. It's kind of like deciding at the very beginning. Are we going to build one massive, all-in-one skyscraper, or a sprawling city of smaller, more specialized buildings? So, first up is the monolith. Just think of a single giant skyscraper that has absolutely everything inside. Offices, apartments, shops, the whole shebang, all in one structure. It's actually pretty straightforward to get started with, which is why a startup with a small team might go this route to get their product out the door fast. But if you decide you want to renovate the plumbing on the 10th floor, well, you might end up affecting the entire building. Now, on the flip side, we have microservices. This is like our city of specialized buildings. You've got a power plant over here, a library there, a hospital down the road. They all work together to make the city run, but you can completely renovate the library and the power grid doesn't even flicker. Each service can be scaled up or updated all on its own. And this table, well, it lays out the trade-offs perfectly. A monolith is simple to start, but man, it can be a beast to scale later on. Microservices, more complex to set up for sure, but they offer incredible flexibility down the line. You'll even see a third option here, serverless, which is kind of like magic. It scales automatically, but you're pretty tied to your cloud provider. There's no magic bullet here. It's always about picking what's right for the specific project you're working on. All right, blueprints picked. Now we need the actual building blocks, the materials to construct our city structure. And, just as importantly, we have to make sure all the different parts can actually talk to each other effectively. So let's talk about the storefronts of our city. You know, the part you actually see and click on. That's where front-end frameworks come in. You're looking at the big three right here. React is super flexible, letting developers mix and match other tools. Angular is more of an all-in, opinionated deal, which is great for huge teams that need that structure. And Vue? People love Vue because it's often the easiest to get started with. They all help create those slick, responsive user interfaces we all expect, and they do it fast. Okay, so this is a really big deal. How do all of these separate buildings in our digital city talk to each other? You know, the power plant has to tell the hospital it's got power, right? The library needs to check with City Hall. Well, that's where APIs come in. They are literally the roads and the phone lines of our digital city. And just like you have different kinds of roads, you have different kinds of APIs. Think of REST as your standard, reliable, well-understood city grid. GraphQL is more like a personal delivery service. It goes and gets you exactly what you asked for, and nothing extra. And gRPC, that's the high-speed bullet train, built for pure, lightning-fast communication between critical services. Okay, so we've got our blueprint, we've got our materials, now we need the factory, right? The place where we assemble, package, and ship everything. This is where we get into the really powerful stuff in modern software development. Now, this next part often trips people up, but the analogy here is just perfect. Docker is what creates the standardized shipping containers. It neatly packages up a piece of our application with everything it needs so it can run literally anywhere. Kubernetes, on the other hand, is the port authority. It's the master of logistics, managing thousands of these containers, telling them where to go, and making sure the entire shipping operation runs like clockwork. So why even bother with Docker? Well, it solves that age-old, super frustrating developer problem of, well, it works on my machine. By packing everything into a neat little container, it guarantees the code runs the exact same way everywhere, from a developer's laptop to a massive server in a data center. Okay, so if Docker gives us the container, why do we need this other thing, Kubernetes? Here's why. Managing a handful of containers? Easy. Managing thousands? It is a total nightmare. Kubernetes is the master orchestrator that automates all that complexity. It handles scaling when traffic spikes, it heals itself if something breaks, and it makes sure our digital city never goes dark. You know, a factory is totally useless without a super efficient assembly line and the skilled people who know how to run it. In the software world, we call this culture and practice DevOps. And before I even get into what DevOps is, Just look at these numbers. I mean, wow. It's clearly gone from just some trendy buzzword to being absolutely fundamental to how modern software gets delivered. Period.
So what is it, really? At its heart, DevOps isn't a tool you can just buy. It's a philosophy. It's all about tearing down the old walls that used to stand between the people building the software, the devs, and the people responsible for running it, the ops. It's about collaboration and shared ownership. And the engine that powers this whole philosophy is something called a CI/CD pipeline. This is the automated assembly line for our software. Think about it. Every single time a developer commits a change, this pipeline automatically kicks into gear, building the code, running a battery of tests, and getting it ready for release. It lets teams ship new features faster and more reliably than ever before.
So who's the star player on this modern assembly line? Often, it's the full-stack engineer. This is the person who gets the whole picture, from what you see and interact with on your screen, the front end, all the way to the servers and databases humming away in the background, the back end.
Okay, let's put it all together. Let's see how all these choices, the blueprint, the materials, the factory, the whole process, actually combine to build the real-world applications we use every single day. And here is the most important thing to remember from all of this. There is no single best way to do things. Building a digital city isn't about using the same blueprint over and over. It's about really understanding the trade-offs and picking the perfect combination of tools for the job you're trying to do. And this table is a fantastic example of that in action. Take the e-commerce site. They chose GraphQL, so their mobile app team can request exactly the data it needs, and nothing more, which saves on your data plan and makes the app feel snappy. But now look at the real-time streaming service. For them, every single millisecond is critical. They're going with gRPC because raw speed is everything for a lag-free experience. Different problems, different choices. Both are the right choice for them. So when you zoom out, you see that the modern software stack isn't just one thing. It's a whole ecosystem of powerful, specialized tools. And understanding how all these layers, the architecture, the tools, and the process, fit together, well, that's the key to navigating this landscape and building pretty much anything in our digital world. Which makes you wonder, what's next? I mean, we've got AI already starting to automate testing, optimize these pipelines, and even write chunks of code itself. The next big evolution in this process is probably just around the corner. So I'll leave you with this final thought to ponder. Will the next great digital city be designed not by a person, but by a machine?